Hi, good evening to all. In the last video walk of mine, I think I went a bit fast with the explanation on linear regression using Python. However, a request came in wherein I was asked to go a bit slow, number one, and number two, to showcase you these steps also in a very practical manner. So here is the collab, I would say, the environment of Python where I'm going to work, and I have logged in through my Google ID, and the title of the entire thing, the project, I have given as the linear regression. Now I'm not going to take care of the entire technique of linear regression to understand it as to what it is and how to perform it through Python. I am not using a data right now. What I will do it, I'll just create array of numbers so that we are able to understand how the linear regression actually works. Now here exclusively my focus will be on Python. I'm not going to deviate myself in any other manner. So here you will see that I have I'm using import numpy as np, number one. Now let me just take away the results so that we are able to see also side by side as to what exactly is taking place over here. So here you will find out, number one, that import numpy. Numpy, we know, is a package of Python, which means that we are using numbers in Python environment, and that has to be imported as np. And the package that I'm going to use it is what, sklearn.linear model, because I'm focusing on linear models as of now. Import linear regression. Whether I'll be using multiple regression, that would be coming up in my future videos, and we will see how to understand it. Some of the concepts which were there, which I really find it to be more interesting and to understand it also. So we will see all those things coming in. So I'm going to import linear regression package through the sklearn linear model library. So here you will see that I have created two arrays, okay, using numpy, and I'm labeling the first one as x, in which I have got, I think, 15 numbers I have taken, 5, 15, 25, 35. It is nothing sequence or something, it's just randomly I have taken 5, 15, 25, 35, 45, 55, 65. And I have already explained to you what exactly do I mean by reshaping it, and it is going to lie between -1 and 1 because of the distribution also. In the second one, I have got another array of numbers, 5, 20, 14, 32, 22, so on and so forth, which I have again taken up randomly, and this one I'm giving a label as y. So there are two arrays, x and y, and this also we have seen that x is the input and y is going to be my output, which I have taken care in the earlier video I have explained to you. Now if I go ahead, okay, so let me start running each one of them side by side so that we know what is the output, and whether if there are any errors, then we can go ahead and we can even debug them. So here you will see the cell. Okay, now I have run, so I have already created and I'm saving it also. Now I'm saying show me what is there in x. So you will see it's an array, so I have got array of all the numbers which has been taken care over there. Now I'm saying after this, so let us go step by step to understand as to how the things are working in this particular environment. Now in 27th line, I'm going to run print y, and you will see this x values are coming in the row format, that is 5, 15, 25, 35, 45, 55. It's in row format, whereas y is coming as columns. So 5, 20, 14, 32. So there is a reason behind it also, and by now you must have guessed it as to what exactly it is. Now if I have to run the model, the simple code written in Python is model equals to linear regression, as simple as that. And now here I can go ahead, I can call upon model, and then there we go. And now I'm going to run it by control enter, and you will see that it gives you the information that yes, this model is about linear regression. Copy underscore x as true, fit intercept is also true, these are the parameters. N number of jobs is none, normalize is false. That means I have not yet given anything to do with the normalization of the data over here. So that's what it gives us the meaning. Then if you go to the next step after this, now it is asking, I want to go ahead to see what is the model fit of the x and y. So it gives me the answer that, now let me just remove the outputs basically here, so that you are not able to see beforehand only. So model fit gives you what? Model this one, and the answer is coming as what? Linear regression. The same thing, I have not given anything else, I have not passed any values or anything. Next they are telling you is that model equals to linear regression. First of all, complete with the linear regression, and then you fit my model in terms of x and y. So what will happen if I run this particular program, the script, you will be getting the same thing, that yes, now you have gone ahead and taken care again of the linear regression. Now I want r square, because you see linear regression is there, model is also there. Now I am saying go ahead and take the scores of x and y present for my model and show me the values of the r square. So if I go ahead, I'd run, I'm getting the value as 0.48255 4595362208. Now you should remember that after decimal points in Python, this is the best way, is that it takes 11 places, 11 digits have been there after the decimal point. So if you want, you can take it. Now most of the time I have seen that individuals who are working in the Python environment, they prefer to keep the numbers for the precision sake. However, you can round off if you are copy paste, you can copy paste it in Excel, and we know how to go ahead and even round it off to 2 digits places only. Now if I go ahead with this one, after running it, fine, I have got. Now I'm giving the command to through Python, print coefficient of determination and r square. So now have a look at it and see what answer you would be getting it over here, and you can see it very clearly that coefficient of determination is nothing but 0.4825545, and this is the answer that I have got over here. So you can compare it with r square and this one and see whether they are same also or not, and you will be seeing that yes, coefficient of determination is nothing but my r square. So you can go forward, and now after finding it out, I'm saying show me the intercept value. So here if I go ahead, I print it, I've got the answer, the intercept as 14.24404, and this is the value that I have got. So let me just remove these things also, so that you are able to see the results again. Now here this is not wanted basically, so let me just delete it. Now next one after intercept is print the slope. I'm looking for the slope and the model coefficient. What is it? You print. Now you see the main importance of print command is that whatever you have I should say earlier step you have calculated it, finally you want an output, so there won't be any revision into it. So at that moment you will be using the print command, and that's why you have got the slope as how much? 0.30785,714. Now you are asking the thing. Now you really would like to know what is the new model for me. So how are you trying to do it? Linear regression, you're fitting in your inputs and outputs, that is your x as well as the regressors and the predictor, and you are giving it a shape that let it be between -1 and 1. Okay, so if you again call the new model which is there, if you really want to understand, so here is the new, I mean they're giving you this one. However, we will go ahead, once I give it a print command, you will see that the value of the intercept is also given to me. So I have got slope, I have got the intercept. So now I can proceed further, and I would say that yes, now tell me what is the y predicted value once I'm able to understand the value of the predicted x. So here you can see, now in Python we go from right to left. So how would you read model dot predict, that is in terms of the inputs, that is x value, I'm going to know what is the predicted y value. Okay, and if I want to understand what those prediction is all about, and you can see it has created an array of numbers for me. These are the corresponding y predicted values when x has been given to us. So we have seen earlier x values are there, so I can go ahead and I can do the prediction, keep these values in front of me, and then try to understand about my model. Now the next step, if you will see, print predicted response, because I'm interested in y prediction only. So if I go ahead, I take a printed value, you will see that now array will not be there, it would be giving to me that yes, it's a predicted response. So you are getting those numbers in front of you again, which is the y values, predicted y, and from here you can go ahead and try to understand what kind of data we have got in front of us. So after this, what are we going to do? I have to now find out basically as to y prediction values we have taken. Now if I have got the y predicted value, now I want to understand model, intercept plus model coefficient into x, that is the input. This is how you are going to design your model, right, and go ahead with the y prediction. So at that time, this is the way you are going to write. Again, I'm repeating it, y underscore pred means that it's the predicted y value. How are you getting it? Through model intercept plus model coefficient into x. Okay, so once you have got these values, this is the formula, and now I'm saying you print the responses for me. What is the code? Let's understand it. You're printing it, that means I want the final answer about what? About the predicted responses. From where you're getting it? You're getting it from the y underscore predict. Okay, and you're separating them by the lines that are there for you, that means commas, and then you will see if I run about it, you can see that now instead of giving it one after the other, it is giving to you in a column manner. So 15.783333, 18.861, and then 21, 25. So you can see all the 15 values are there, and these are the y predicted values for you in the linear regression. Now if I want to understand what is the x new in the sense, what if I give new input to the entire model, will I get something else or not? So here I go ahead, and again I have got 15 numbers, so I'm going to run this one, and you will see out here what is the output that I have got. I'm getting, if I take it up, 0 1 2 3 4 5 6. Now you see, I told you in Python it never starts from 1 2 3, it will be starting off from 0. So it will be 0 1 2 3 4 5 6 8 till 14, it will be showcased to you. Now I'm saying show it to me against these columns that I have got in front of me, the rows for x new. Show me what is the y new. So how are you trying to do the prediction out here? Have a look at it in this manner. Let me just first of all run this. Okay, and now I have to see what are my values. So can you see what are the values? 14.2440476 14 points. So these are the 15 numbers that I have got for me for the linear regression. So this is how we will be doing, and let me proceed further in my next video walk, wherein it is not just getting the numbers in front of you. However, we will even visualize it and try to see as to how the things are coming in using the Python. So this is just part of it. So let me come back with more videos on linear regression, doing it through, I'm using Python programming language in order to understand how to proceed further with the linear regression. Thank you for watching. Take care. Bye.